this is question 21 from the 2003 higher paper. First question there, the horizontal component of the initial velocity of the ball. So this value that you're given here, that's 35 meters per second, you're never going to use that on its own. You need to, if something is launched at an angle, you need to resolve it into its component parts. So its horizontal component of velocity and also its vertical component of velocity. And you need to treat those really as two separate things. So if we're doing the calculation for the horizontal velocity first, then the horizontal velocity is v cos theta. Remember, if you get them mixed up, then think about cos across or going horizontally. That usually works for projectiles, won't always necessarily work for forces. That's the only thing to watch out for. So that's 35 cos 40 degrees. Gives 26.8 meters per second. That's your horizontal component of velocity. Part 2, the vertical component of velocity, you've already done v cos, so the vertical component must be v sine theta. You can figure that out using trigonometry if you want to, but it's probably easier just to remember. So it's 35 sine 40 degrees is 22.5 meters per second. So now you've got pretty much everything that you need in order to perform your calculations in part 3 and also in part B. The time taken for the ball to reach its maximum height at point P. Well, this is maximum vertical height, so I would deal with only vertical here. So we're going to be looking at suvat. S is what we're trying to figure out. U is your initial component of vertical velocity, which is 22.5. V at its maximum height, its velocity must be 0 meters per second. It's going up, so we use negative 9.8. And the time is, we don't know. We're trying to figure that out. So we're looking for t, we've got u, v and a, so I'd use v equals u plus at. So 0 is 22.5 minus 9.8 t. 9.8 t is 22.5, so t is 2.3 seconds. So it's 2.3 seconds to get to its maximum height. That's 2.3 seconds for this little part of the journey. For part B, calculate the total horizontal distance travelled by the ball. So that's this range here, as it's sometimes called. So all the way from here over to point R. Time to rise we know is the same as time to fall, so if it takes 2.3 seconds to get up to P, it's going to take a further 2.3 seconds to get from P to Q. We've got an extra bit there which makes things a wee bit more complicated, but we're given what that value is. That's 0.48 seconds. So we know the total time of flight. We also know what the horizontal velocity is, because if the horizontal velocity starts out at 26.8 meters per second, it's going to remain at 26.8 meters per second all the way through. So for part B, what you're looking at is total time, first of all. So that's going to be 2.3 multiplied by 2 plus 0.48 will give 5.08 as your total time. If you're looking for horizontal distance, you need to do horizontal velocity multiplied by time. So that's 26.8 multiplied by 5.08 should give you 136.14 meters. So that type of question really tests your knowledge of projectiles, you know, of the fact that it's travelling horizontally at a constant speed, that it's being accelerated downwards due to gravity. You need to choose the correct signs in there as well. You also need to know that the time to rise is the same as the time to fall. All that stuff is typical of a projectile style question. So if you can do that, then you should be alright with projectiles.